Hi everyone, so I'm going to give you a video tutorial on how to do Lab 10, which is Venus and the greenhouse effect. To access the lab, you're going to go into your course content page, click on week 5, Lab 10, clicking through, and here we are at the lab. So for this lab, as with some previous labs, you're going to need Stellarium. If you don't have Stellarium yet, you can download it at stellarium.org, but you probably should have already downloaded it for the previous labs. So let's get into it. So opening up Stellarium, the first things we're going to do is set our location to Phoenix in the United States. We can do that by coming over to this left panel here, going to the location window, and for me it's already set to Phoenix, but if it's not for you, then you can type in Phoenix to the search box and click it right here, and that should set your location to Phoenix. We're also going to set the date and time to a standard date, so for us that's going to be March 24th 2018 at 8 a.m. This is important so that the stars and planets all show up where we expect them to. Basically, we want to have a consistent standard for you to be measuring from. So to do that, we're going to go to the date time window and put in 2018 March 24th. We're going to go to 8 o'clock. And then if you come down here to this button, the play button, you can click that to pause the time. So, what are we going to do? So, what we're doing today is investigating Venus. Currently we can't see Venus because it's bright out, there's too much light. So what we're going to do is turn off the atmosphere. You can do this with this button here or by pressing the A key. We're also going to turn off the ground so that for later you're going to be able to see below the horizon, which will be important. So as we can see, Venus is right here. And your lab's going to ask you a whole bunch of questions about Venus. What is its radius? What percentage of the Earth's radius is that? What is its mass? Its angular size? Etc. How far is it from us? How far is it from the sun? So in order to find that out, we're going to left click on Venus. And when you do that, you should have these targets around it, and it's going to show you all this information right here. So for instance, this is its apparent magnitude, this is its orbital distance, its distance from the sun, this is the constellation it's currently in, etc., etc. This is its apparent diameter, and this is in degrees, arc minutes, and arc seconds, for those of you not familiar with that notation. And so two things about doing this part of the assignment. For one thing, I don't know if all of the information is contained in this list. So for instance, I'm not sure if the mass of Venus is here in this list. So if you find a question asking you about something that isn't in this list, you should just look it up on Google. Or your favorite astronomical resource, I guess, and you should answer the question that way. Additionally, not all of the answers are exact, but if you choose the closest one and you're within like maybe 10%-ish of the answer, you're probably going to be fine. So which constellation is Venus on, you can answer that either by using this, or you can turn on constellation lines and also labels. And those use these two buttons down here. You can press C and V or just turn them on with these buttons. And you can also press B to show boundaries between the different constellations. But either way, you should go ahead and answer that. Oh yes, and the distance at inferior conjunction and superior conjunction. Basically what that's asking is, what is the farthest Venus gets away from Earth, and what is the closest Venus gets to Earth? And you should be able to answer that by adding and subtracting Venus's orbital distance from the Sun from Earth's orbital distance from the Sun, which, as you know, is just 1 AU. So that'll be how you do that. So in addition, we're going to be looking at Venus's orbital characteristics. Excuse me, I'm going to take a drink. So, particularly we're going to be looking at the elongation of Venus, the greatest elongation in fact. And so, in order to do that, what we're going to do is we're going to, I'm going to click away from there. We're going to go to the Sky and Viewing options window, which you can access with F4. We're going to show planet orbits, which is this check mark. Show planet orbits only. Basically all these, whoops. No, go back, thank you. All these three boxes should be checked. We can close that. And I'm noticing this is getting a little laggy when I have these orbits on, but hopefully your computer can handle that. And we're going to click on Venus again, and then what you see here is Venus's apparent orbit in the sky. This is what Venus's orbit looks like to us. So this is a bit tricky. So what we're going to want to do is move forward from this date, August 17th, 2018. So let's set the date to that right now. It's August 17th. And here we go. So here's Venus. And as you can see, it's sort of at its most distant, basically it's most distant from the Sun, which isn't, it's not physically more distant from the Sun, but from our perspective here on Earth, its angle between it and the Sun is currently greatest. So from there, you're going to move time forward from this time, and as a note, you can press T, the T key, and that will track onto the object that you're looking at. Now there is some trickiness to this in the sense that as you move time forward, and how did I do that? I did that by pressing the L key. If you press the L key or press this increase time speed button, you'll increase the rate at which time is moving, so you'll see the planet move faster, and you can press T key again to lock onto this one. So the question asks you, as you're doing this, what is the maximum elongation that you find? And physically, the elongation is the angular distance between a sight line from us to the sun and a sight line from us to Venus. What is this angular distance across here? And that value is right here in this data box, I guess you could call it. And you're basically going to want to answer what is the greatest angle that you see as you move forward in time from August 17th. As you basically cusp around this bend, this elongation is going to maximize, and that maximum value is what your answer should be. After that, it asks you what the next occurrence of the greatest elongation of Venus is. So what it's asking you to do is to move time forward, and as you do, you'll see Venus come back around this path all the way over to this point in its orbit. And at that point, it will have reached its next greatest elongation, and you're going to ask, or you're going to answer, excuse me, what date that happens on. And again, this might not be exact, but try to find the closest one. And I'm going to try to do that right now, but oh gosh. So I'm not sure how to, I guess, lock the sky in such a way that the orbit doesn't shift around as much. And so it's pretty jarring to watch it scrub forward. I'm sorry that I don't know how to fix that. But if you go forward enough in time, you should see it follow along this path, or possibly this one. I'm not sure. Let's check. Oh gosh. Again, press T to track the object. Oh gosh. Okay, so it's actually following the bottom path, and it'll follow it all the way to here, and you should you should answer what date it reaches this point at, and then you'll see it swing back around all the way back to where it was initially, around August 2018, and you should say what date that was as well in your lab. Okay, so the next question asks you to find the position of Venus as seen from outer space. So what we're going to do here is we're going to open the location window again, and we're going to set the planet in this planet box. We're no longer going to be viewing from Earth, we're going to be viewing from where is it? Solar System Observer is what we want. And if you type in solar, it should bring it up in the box. Okay. So what we're doing now is looking at a location, or looking from a location, I should say, far outside of the solar system. And we're actually looking down at the orbital plane of the planets. So if we look in here, here is the orbit of, I don't know which, I guess this is probably, let's see. So here we have the orbit of Mercury, the orbit of Venus, the orbit of Earth, and the orbit of Mars. And these are the outer lying planets. So I guess this is Jupiter, Saturn, Uranus, Neptune. And Pluto's not a planet, but you already knew that. So again, we're going to be focusing on Venus. And the question is going to be asked on March 24th, 2018, which object appears closer to Venus? So we're going to set the date to March 24th. And you're going to say which object is closest to Venus at this point. And then you're going to do that again for August 1st, which is what? 8-1. Yeah, so you should answer that question again then. Okay, so I'm gonna take another drink. Okay, so this next question is going to ask you to actually observe from Venus. So let's go ahead and do that. The way to do this is, okay, again, we're setting our date back to March 24th. And we're going to set our location to Venus, again in the Planet tab. So, what can we see? I'm going to zoom out. I don't know if this is the realistic atmosphere you'd see from Venus, but that's fine. So this is what things would look like from Venus. And in theory, if we look around, you can see Earth from here actually, and the moon right next to it. Oops. So, to Stellarium, and we're going to face west. Where's the ground? There. So we're basically on the surface of Venus right now, facing west. And what we're going to do is we're going to try and calculate the length of a solar day on Venus, which in this case is going to mean the amount of time between two sunrises. So if we, right now I'm pressing J and L to reverse time and speed up time. And so we, in this case, we see the sun peeking over Venus's horizon at, you can read it right here, so this is April 11th. And what we're going to do is we're going to move time forward until we see the sun peek up over the horizon again. And then we're going to stop it, and we're going to see what that time is. Okay, so we can reverse a bit until we just see the sun peeking up over the horizon again. And we see that this happened in August 5th actually. And so what you're going to do is you're going to find out how many days were between that first day and that second day. And you're going to subtract those from each other, and that tells you how long a solar day is. It's just how long did it take between sunrises. And that's your answer for that. Now for the sidereal day, you're actually going to be able to find it right here in the info box for Venus. I believe we're still selected on Venus. If we turn the ground off, yeah, so we see that these red markers are around Venus right now. So this is the info for Venus, and that's your sidereal day. You might have to convert that from hours to days using Wolfram Alpha or Google or, you know, pen and paper, whatever you feel like. You're then going to find the percentage difference between those two values. So you're going to take the difference between a sidereal day and a solar day, and you're going to divide it by the length of a sidereal day and multiply that number by 100%. So what is that percentage difference? You should calculate that and answer that right here. And lastly, we're going to determine how long a year is for Venus. To do this, we're again going to go to the Solar System Observer view, and basically we're going to, well, yeah, let's do that first. So we're back in Solar System Observer view, and see the sun here, and Venus here, and I'm gonna scrub forward a little bit again with L, and basically, so I'm gonna note, so currently it's it doesn't matter exactly where Venus is, but what you're going to measure is the amount of time it takes for Venus to go around in a complete circle. So right here I see September 18th, and if I press L a bunch of times, eventually I will see Venus come back to the same place. And this is, what, May 2nd, so, you know, a number of months later. So again, you're going to calculate how long that took, and that is the duration of a year on Venus, by which we just mean Venus's orbital period. Okay, so the next part of the lab is going to ask you about basically atmospheres and how they absorb and reflect photons, basically, which is, you know, light, but also other, you know, also in addition to visible light that we can't actually see, but does still carry a lot of energy. So you're basically going to read through this part and answer the questions based on the figures here. And you're going to continue on to here, and again, you'll get some figures, and you should answer the questions based on those figures. And I believe you'll be able to figure out how to do that for yourself. And of course, if you can't, there is always the discussion forum where you can ask questions about all that kind of stuff. So, yep, that's the end of the video. I hope it was helpful, and